All right, so we're starting on the isosceles and right triangles by determining the value of x in each isosceles triangle. So let's start with number 1. They give us this isosceles triangle over here, and it looks like these are the congruent sides because it says 8-inch and 8-inch, so they must be congruent. And then they also have the altitude drawn right in between it. I think I used green before, so I'll use green again. So this line that I'm drawing here, it bisects the vertex angle, which means that this top angle must be the same as this bottom angle. So they are congruent. If they are congruent, then they have the same measure. So x is equal to 32 degrees. Simple. Okay? Does anybody have a
Miss
question?
Jane, I think you froze again.
Oh, I'm so sorry. Okay. Let me re-explain that. Thank you for letting me know I froze. Okay, so what I was trying to say was that we are given this isosceles triangle. Okay, this is literally, let me look at the notes. This box number 35. Okay, so look at box number 35. We have isosceles triangle where the altitude bisects the vertex angle. Go back to skills practice. Our isosceles triangle is kind of sideways, but that's totally fine. It's still going to bisect our vertex angle. So this angle C, that's our vertex angle. The altitude cut it into this piece and this piece. It bisects it, which means that those two angles are congruent. Those two angles are the same measure. So if they're the same measure, then x must be 32 also. Did you guys hear me this time?
Yes.
Yeah.
Okay, thank you. Okay, so now that you heard me, do you have any questions on this one? Okay, interrupt me if you do have a question. Let's go on to number 2. So we have another isosceles triangle. It looks like our congruent sides are over here and over here because they are 20 feet and 20 feet. Let me just double check. Okay, cool. And then we have this altitude right here. This green line is our altitude, and the altitude bisects the base. So we have our base over here, and it gets bisected, which means it gets cut in half. So if our base is 26 feet, what do we have to do to 26 to get our
Divide by 2.
Good, divide by 2, thank you. 26 divided by 2, and then we get what as our answer?
13.
13, thank you. And then 13 feet. Because our unit was in feet, so I want to make sure I use the units. 13 feet. Anybody have a question on this one?
How do we get 13 again?
We took the 26, which was the overall length of this blue side. See the blue side? We took the 26, because they told us it's 26, and we divided it into 2. Because look at this green line. This green line cuts the blue side in half. So our green altitude bisects our blue base. So we cut it in half. That's what bisects means. So you take 26 and you take half of that. 26 divided by 2 gives us 13. Any other questions? Okay, let's go on to number 3 and 4. So let's take a look at number 3. We have our 2 congruent sides over here. We have our altitude. And look at that altitude cutting our angles in half. It's bisecting our angle. That's great. We already knew it would do that. And then we have one of these half bases being 4. That must mean this other side is also 4, right? Because it's being bisected. So if we have 4 on one side, the other side's congruent. The other side is also 4. And then they're asking us for the total base length. So we have 4 plus 4, or 4 times 2, however you want to think about it. However way is okay. You get 8 as your answer. So x equals 8. Because x is the total length of the base, right over here. And each half of the base was 4. So 4 times 2, or 4 plus 4. Any questions on that one? All right, let's do another one. Number 4, we have our congruent sides over there. We have our altitude, which bisects our angle right over there. Just somebody shout it out. What is our x value?
37.
37, good job. And we know that because our altitude bisects the vertex angle. Sorry, I'm pretty sure you were going to say that. Next time I'll let you guys explain. But good job. And thank you. Does anybody have a question?
Is it 86 or 36?
Oh, sorry, that's a 37.
Oh yeah, 37, okay.
There we go.
Miss Jade, I think something's wrong with my Chromebook.
Oh, is it, what's happening with it?
So basically, like,
All right, so now we're on to section B, and the instructions say, determine the length of the hypotenuse of each 45, 45, 90 triangle. Write your answer as a radical in the simplest form. You guys are gonna love how simple this is. Let me show you how the equation is on the notes. Where is the 45? Over here, okay. So we're looking for the hypotenuse, and so the equation's right over here. Hypotenuse, oh, I'm lagging, my bad. Give me a moment. Okay, so that is our equation because we're looking for the hypotenuse. It's literally leg times radical 2. So watch how this works. Our leg is 2, so our hypotenuse is 2 radical 2. Our leg is 5, so our hypotenuse is 5 radical 2. Okay, what about for number 3? Our leg is 9, so our hypotenuse is what?
9.
9 what?
Hypothesis 2, something like that. I don't know how is it pronounced.
9
Oh, yeah.
hypotenuse 2.
9 radical 2. Or you could say 9 root 2. Okay, so this is 2 root 2, or 2 radical 2. Okay, so now that you know how to say it, our for number 4, our legs are 7, so our hypotenuse is?
You're frozen.
Miss J, you lagging again.
Oh my gosh, I was like, why aren't they responding to me? Okay, yeah, no, I froze, my bad. Can you hear me now?
Yes.
Okay. Okay, so I was saying for number 4, now that you know how to say it, we know our leg is 7, so our hypotenuse is what?
7 radical 2.
Perfect, 7 radical 2. Good job. Wasn't that one great? That was so simple. You literally just write the same number, radical 2. Any questions on that one? Alrighty, let's move to the next section. Determine the lengths of the legs of each 45, 45, 90 triangle. Write your answer as a radical in simplest form. Okay, so this one, let me show you our equations again. We have leg is equal to hypotenuse divided by radical 2 or hypotenuse radical 2 over 2. Okay, and so these two are equivalent. It's just that when you have an answer, you don't want the radical on the bottom. I'll just show you what I mean in a moment, okay? So I'm going to write this out. I'll write it here. Leg equals hypotenuse over radical 2 equals hypotenuse radical 2 over 2. Okay. So for number 1, our hypotenuse is 16, right? And then since there's no radical here, we're going to use this formula for our leg.
Miss Jade, can you
Yes?
zoom into the equation a little more,
Oh, yeah.
please?
Is that better?
Yes, thank you.
Okay. Yes, you're welcome. Sorry. Okay, so my messy equation says hypotenuse radical 2 over 2, and you use that when your hypotenuse is a whole number. Use when hypotenuse is whole number. Okay, so our leg, is 16 radical 2 over 2. Let me write it again, 16 radical 2 over 2, and that's our answer. So once again, this is the equation you use when your hypotenuse is a whole number. I'm going to show you for number 3. Look at our hypotenuse. Our hypotenuse has a radical. So this is the other equation. You use it when hypotenuse has radical 2 in it. You're going to use hypotenuse over radical 2. So this other equation, we're going to use it when our hypotenuse has radical 2 in it. They're the same equation, it's just a different way of writing it. Okay? So then, let's calculate our A value. Our A value is our hypotenuse divided by radical 2, and they get to cancel out. So the answer is 6. Let me zoom out just a little so I have more space to write. The same thing on the bottom, it's just 6. Okay? Any questions on this one? Don't forget to write notes because you get to use your notes on the test, any test, all the tests. Always get to use your notes.
Miss J, you lagging.
I know. I just drew a happy face. You see the happy face? I drew it so that I could see if I was lagging, and I was like, oh, I know I'm lagging. Okay, so what I said was that you use this bottom equation, hypotenuse over 2, when your hypotenuse has the radical 2 in it. And then on the top, you use this equation, hypotenuse radical 2 over 2, when your hypotenuse is a whole number. Oh, actually, you know what? I just noticed on number 1, I didn't simplify this. Can you guys help me simplify what is 16 divided by 2? I'm lagging, aren't I? Okay.
Nah, 8.
8, okay. My image is lagging because I drew something and it's not appearing. Let me just wait for my image to catch up. And thank you guys for being patient. We're gonna probably take a little longer today just because my internet's being weird. Okay, so 16 over 2, we said that was 8. So our answer is actually 8 radical 2. So this is equal to 8 radical 2. Okay, so I didn't simplify the top one, my bad, but now we simplify it. My point was that when your hypotenuse is a whole number, you use this equation. When your hypotenuse has the radical, you use the bottom equation. Let's apply this onto the other two numbers. Okay, so number 2 has our hypotenuse as a whole number, so we are using this hypotenuse radical 2 over 2 equation. I am lagging. My image is
You're
lagging so much.
frozen, Miss Jade.
I know. I'm so sorry. I don't even think you can hear me say sorry. Can you hear me? Yep, that's a no. Okay. I'll wait. Okay, so I heard you guys say I was frozen, and I apologized, and you didn't even hear me apologize. But we're using this hypotenuse radical 2 over 2 equation because this hypotenuse is a whole number. Okay, so let me just highlight that. Whole number, whole number, whole number. So we use this equation to go with it. So let's put it into the equation. We have a is equal to 12 radical 2 over 2. Let's simplify this. What's 12 divided by 2? 6. Good. So our answer is 6 radical 2. And then that's the same thing over here, 6 radical 2. Okay. And finally, on number 4, it has a radical in our hypotenuse. So we're going to use this equation, hypotenuse over radical 2, because it has a radical 2 in it already. Okay, so that's the formula we're using. So let's plug it in. We have 8 radical 2 over radical 2. Let's simplify it, cancel it out, and we are left with 8 as our side length. So our answer for these is 8. Okay, do you guys have any questions on this one? Okay, we're gonna do some word problems now. Over here, let's take a look at number 1. I'm gonna end up drawing a picture because I think pictures always help us. Okay, so number 1, Soren is flying a kite on the beach. The string forms a 45-degree angle with the ground. If he has let out 16 meters of line, how far above the ground is the kite? Okay, somebody wants
You
me to-
lagging.
Frozen.
Oh, okay. Let's give it a moment. I don't even know if you can hear me, but I'm just saying, let's wait until I stop lagging. I apologize. Okay, so somebody wanted me to go back, so here I am going back. I also heard that I was lagging. So the person who wanted me to go back, type done when you're done, so that I know when to go forward. All right, let's go forward now. Hopefully I don't lag again. Please, internet. Okay, number 1, Soren is flying a kite on the beach. The string forms a 45-degree angle with the ground. If he has let out 16 meters of line, how far above the ground is the kite? If you're
You
like,
lagging again.
oh my gosh. Okay, thanks, Nico. Let me read it again. Soren is flying a kite on the beach. The string forms a 45-degree angle with the ground. If he has let out 16 meters of line, how high above the ground is the kite? So I like to draw a picture. I highly recommend you draw a picture too. So here's this Soren person, right? He's flying a kite on the beach. His kite forms a 45-degree angle with the ground. Okay, if he has let out 16 meters of line, that's his little, kite thing. Right, that's his kite. Okay. How high above the ground is the kite? So we are looking for how high above the ground. That's this. We are looking for this. We are looking for that green height. So really what we are doing is we have a 45, 45, 90 triangle, and we are looking for the leg, but we are given the hypotenuse. So just to remind you guys of our equations, we have leg is equal to hypotenuse over radical 2 is equal to hypotenuse radical 2 over 2. Okay. Oh, my internet connection was unstable. All I did was I wrote out the equations that you guys already know. And so since we have a whole number, we're going to be using this version of the equation to find our leg. So let's plug it in. We have 16 radical 2 over 2. And help me simplify, what is 16 divided by 2?
8.
8. Good, so our answer is 8 radical 2. They want us to round our answer to the nearest tenth if necessary. So we have to find out what 8 radical 2 is. So I'm going to use my calculator and I'm just going to type it in. 8 times radical 2. Radical 2 times 8. So if you type this in a calculator, you will get 11.3. I'm rounding it to the nearest tenth already. So how high above the ground is the kite? 11.3 meters. Do you guys have any questions? Okay, let's go on to number 2. Mina is picking oranges from her tree in her yard. She rests a 12-foot ladder against the tree at a 45-degree angle. How far is the top of the ladder from the ground? Okay, here's my tree. Might as well use green. Sorry, my tree looks really like weird. And then she has a 45-degree ladder. Here's her ladder. I'm going to draw it with really, really bad artistic perspective. Just please ignore that. But here's her ladder. It makes a 45-degree angle with the floor. Okay, and of course, we want to find out how far is the top of the ladder from the tree. So I'm going to use this green dotted line to represent the height of the top of the ladder. That height makes a right angle with the floor. We are looking for the distance from the top of the ladder to the floor. So we are once again looking for the leg of a triangle. When we are given the ladder is, the ladder is 12 feet. Okay, so we're going to use the same formula. We have the leg is equal to hypotenuse, radical 2 over 2. Oh, I'm so sorry. Oh, okay, let's wait for it to catch up. I'm so sorry. Okay, so I just labeled the ladder as 12 feet, and I said that the equation we're using is the same equation, hypotenuse radical 2 over 2. So let's plug it in. We have 12 radical 2 over 2. Can you guys help me simplify? What does this become?
Six.
Thank you. 6 radical 2, yes, thank you. And then, oh wait, I don't want to box that one because we want to round it to the nearest tenth, so I'm going to type it on my calculator. What is 6 radical 2? Let me see. That would be, on the calculator, 8.5. And we're talking about feet. So 8.5 feet. Okay. Do you guys have any questions on that one? So whenever you have word problems, make sure you are drawing pictures, okay? All right, let's keep going. Let's see, we have half an hour. Will we make it? I'm gonna skip those 2 word problems on the bottom. It's okay if we don't do them. I just wanna make sure I get through the, not 45, 45, 90, but the 30, 60, 90 triangles as well. And since we are lagging, since I am lagging so much, I'm afraid that we might not make it through the whole thing if I don't skip it. Okay, so I'm sorry, you guys are doing great. Like, you guys are making a great pace out of this. It's just, it's like my internet, so I apologize. Okay, so for part E, we are determining the measure of the indicated interior angle. So let's take a look at what they even want out of us. They want the measure of angle ABC. Okay, straightforward. So we're going to start at A. So starting over here, go to B, and then go to C. Okay, so we want the measure of this angle. Okay, and we have an equilateral triangle, which means that all three angles are equal anyways. Remember that the total sum of any triangle interior angles is 180. So if we want one of those angles, you just take 180 divided by 3, and you'll get 60 degrees. So in an equilateral triangle, they're all 60 degrees. All the angles are 60 degrees. So measure of angle ABC is 60 degrees. Any questions? Alrighty, so number 2, we're going to determine the measure of DFE. So start at D, go to F, go to E. We want this measure. Okay, and so let's see. We have a highlighted triangle right over here. I'll highlight it in green. And let's call the DFE angle, let's call it X. So we have 30 degrees plus, that's a 90 degrees plus X. All of that should equal 180. And so 30 plus 90 is 120 plus X equals 180. We can subtract 120 from both sides, and you will get that X is equal to 60. So in this case, measure of angle DFE is also 60 degrees. Any questions on that one? Okay, let's go on to the next one. So for the next one, we have HAK. So let me just highlight that angle. We start at H, we go to A, we go to K. So we are looking for this angle right over here. Oh, okay, I have a person that says wait. You can still see everything, so I'll just wait here. Remember to type when you are done. Cool, so we have a flat line on the bottom right here. So JAK is a straight line. And we know that on this left side, we have a 90-degree angle. And so on the right side, whatever this is, oops, I'm kind of already drawing it, but whatever this is, it must be a linear pair with a 90-degree angle. So a linear pair means that they form a straight line together. Here's our straight line. They form a straight line together. And linear pair also means they add up to 180 degrees. So let's just call this X. We have 90 degrees plus X equals 180. Then you subtract 90 minus 90. You get X is equal to 90 degrees. So I saw that my internet connection was unstable. So what I just said was that this angle and our X angle are a linear pair because they form this straight line. And when they form a straight line, it means they add up to 180 degrees. So I set it up over here. I made them add to 180, solve for it, X is 90. Any questions? Okay, and last but not least, we have number 4, which is TRA. So let's go from T to R to A. So we are looking at that angle. Let's call this x. If you highlight this green triangle again, I'm just gonna quickly highlight it. If you highlight this triangle, remember that every angle in here must add up to 180 degrees. So we have x plus 60 degrees plus, that is a 90-degree angle right there. You add it all up, you'll get 180. And then let's combine these. X, let me use a different color. X plus 150 equals 180. Subtract the 150. Oops. And you get that x. Oh, what the heck? Okay, there we go. Yeah, we're here. X is equal to 30 degrees. So measure of TRA is 30 degrees. Any questions on these? Okay, we're almost done. Let's go to the next section. Unless somebody needs to still wait here, please type wait if you need wait. Okay, no one's typing it, so I'm going to scroll on. On to the next section. We are given the length of the short leg of a 30, 60, 90 triangle. We're going to determine the length of the long leg and the hypotenuse. Write your answers as radicals in simplest form. Let me show you on the notes where it is. Not there. It's right here. So long leg, I'm going to point. Long leg is equal to short leg times 3. And hypotenuse is equal to 2 times the short leg. Let me write that out. I'll just write here. Long leg equals short leg radical 3, and hypotenuse equals short leg times 2. Let me zoom in for people. Okay, so those are the formulas. I just wrote them out. They are in your notes already though. So let's put it all together. Hopefully you guys will figure that this is also a straightforward one. So let's do our long leg. Our long leg is short leg times radical 3. Done. Our hypotenuse is short leg times 2. So 3 times 2 is 6. Done. Okay, let's do another one. So for number 2, we got 5 inches as our short leg. So let's do our long leg first. Our long leg is short leg times radical 3. Done. Our hypotenuse is 2 times the short leg. Or short leg times 2. I guess I should write it out the other way to be consistent. Short leg times 2 equals 10. Done. Any questions on those two? Okay, let's do 3 and 4 now. So it's the same process, okay? Let's do the long leg first. Long leg is short leg times radical 3. Okay, in this case, we gotta simplify it. We have 2 things under a radical, so we got 6 times 3 here. 6 times 3 is 18. And we need to simplify this radical. You have to think to yourself, is there any perfect square? Perfect squares are like 1 squared, or 2 squared, or 3, squared, or 4 squared, which is 16, or 5 squared, which is 25. Do any of those fit into 18? Does 1 fit into 18? Does 4 fit into 18? Does 9 fit into 18? So if you think to yourself about that, you will realize that 9 fits into 18. 18 is 9 times 2, right? I know this is getting slightly more complicated, but it still should be review stuff, things you've seen before, even if you've forgotten it. So 18 is radical 9 times 2. And so this is radical 9 times radical 2. We're just kind of separating it out now. And this is equal to 3 radical 2. So all in all, we simplified our long leg to be 3 radical 2. So if this was confusing, it's okay. Write it down in your notes. Tell me if you have any questions. I'll give you guys 10 seconds to type yes if you have a question. Okay, I'll wait for the question. All right, so we had a question about how did we get to 3 radical 2. So let me explain it again. We start off with knowing that the long leg is equal to the short leg times radical 3. So I wrote that out here. Long leg is equal to short leg times radical 3. That's just me plugging it into the equation. I'm lagging, so I'm going to wait and then I'll re-explain. Yeah, I figured. Okay, I saw that my arrows were not being drawn. So let me say that again. I have this equation. Long leg is equal to short leg times radical 3. So then I use that equation here. Long leg is equal, long leg is equal to short leg times radical 3. Can you hear me now? Yes, okay. So we combine those two radicals, they're multiplied together, so I put them under the same radical together. So it's radical 6 times 3. So that's how we got there. Then 6 times 2 is 18, so that's how I got to radical 18 over there. And then you think to yourself, what is 18? What can you break 18 into? 18 is, you can break it into 9 times 2, so I got here through that. You have to ask yourself if there are any perfect squares that fit into the number that you get. So we got 18. We asked ourselves, do any of these perfect squares fit into 18? And yes, 9 fits into 18. Perfect squares are like the 1, 4, 9, 16, 25, 36. These are perfect squares because they are something times itself. So we found that the perfect square of 9 fits into 18. And 18 is 9 times 2. So I wrote 9 times 2. And then we break it up into 2 radicals. Radical 9 times radical 2. And then we simplify. Radical 9 is 3. So then we get to 3 radical 2. Oh god, I'm talking too much today. All this repeating from the internet. You're welcome. Okay, let's try that process again for number 4. Actually, no, we got 10 minutes. Skip number 4. Let's move on. I'm sorry my internet is so terrible today. It's all the internet's fault, I swear. Okay. Given the length of the hypotenuse of a 30, 60, 90 triangle, determine the lengths of the 2 legs. Write your answers as radicals in simplest form. Okay, so let me show you the equations. So we are given the hypotenuse and we want to use that to find our long leg and our short leg. So we have that the short leg is equal to half of the hypotenuse, and then we're just going to use the short leg to find our long leg. So let me write that out. Short, I'll just call it short, is equal to half hypotenuse, okay? And then the long leg, I'll just use long for that, is the equation we wrote earlier, which is short times radical 3. Okay, so short times radical 3. I am lagging again. Ah, what a day. Okay, so I lagged again, but the long leg is just equal to the short leg times radical 3. And that's the equation we were using for the top examples earlier. Okay, let's keep working. Thank you for dealing with all of the issues that come across from online learning. I appreciate you all. Okay, let's do the short leg first. Is half of the hypotenuse. So we have over here, here's our short leg, here's our equation that we're using. We have 1/2 of the hypotenuse, which is 20. Half of 20 is 10. Okay, so that one's done. And then the long leg is equal to short leg times root 3. So we're going to plug it in. The short leg times root 3. So it's just 10 root 3. Done. Any questions on that one? Okay, let's do number 2. Oh, sorry, I forgot to zoom in. I don't know if you needed it, but I'm going to zoom in now. Okay, so for number 2, we have, let's do the short leg again first. Short leg is half of the hypotenuse, so 16 is our hypotenuse. Divide it by 2. I should write it out with the formula. Give me a second. Half times 16, half of the hypotenuse, and that gives us 8. And we are done with that one. Then let's do our long leg. Our long leg is the short leg times radical 3. So we have 8 times radical 3, and that is it. We are done with that one. Okay, any questions on the first 2? Okay, let's do 3 and 4 and call it a day, okay? Hopefully we can do this smoothly. Let's get through this. Okay, short leg first is half of the hypotenuse. Half times our hypotenuse, which is 6 radical 3. My internet connection just said it was unstable. So let's do our short leg first. Half of the hypotenuse, half of 6 radical 3. That just gives us 3 radical 3. Done. Next one, let's do our long leg. Long leg is equal to short leg times radical 3. So short leg is 3 radical 3 times radical 3. If you have 2 radicals that are the same number multiplied together, well, this will just give us, here, let me write it out. 3 radical 3 times 3, which is 3 radical 9. And what is the square root of 9?
I think 18.
Oh, you're thinking of 9 times 2. I'm saying what times what equals 9? Nathan got it. It's 3. So square root of 9 is like, because 3 squared. Why do my 3's look like that? 3 squared equals 9. So then the square root of 9 is 3. Okay, because squaring and the square root are the inverse operations. So we have 3 radical 9. That's 3 times 3. So 3 times radical 9 is the same as 3 times 3. So our final answer is 9 as our long leg. Anybody have questions on that one? Because that one had a little bit more stuff that we're doing, you know? That one's a little lengthier. Okay, so I know radicals can be confusing for some people, but that's why we gotta keep working with it. If we don't challenge ourselves, then we're not really learning. So I think it's a good thing that we got some challenging radicals here. Let's do number 4, our last one. Let's do our short leg first, so A. So half of the hypotenuse, 1/2 of the hypotenuse. So that simplifies to 2 radical 2. And then let's do our long leg, short leg times radical 3. So 2 radical 2 times radical 3. We have to simplify this, so this is 2 times radical of 2 times 3, which is 2 radical 6. And you can't simplify radical 6, so that's it, 2 radical 6. You cannot simplify radical 6 because there are no perfect squares that fit in there. Remember, the perfect squares are like 1, and, well, I mean, 1 doesn't really help us, but like 4, 9, 16, 25. These are the perfect squares. None of them fit into 6. So our radical 6 is as simplified as it gets. And so this is our final answer. Do you guys have any questions on that one? Oh my god, I was lagging. Okay, I just asked if you guys had any questions. I also said that radical 6 was simplified already because there are no perfect squares that fit into it. Perfect squares being 1, 4, 9, 16. None of those fit into 6, so radical 6 is as simplified as it gets. Any questions? Okay, if there are no questions, then that concludes our notes, and I want to thank you again for dealing with me and my internet and all the times I had to repeat myself, and all the times you probably just stared at a lagging screen. So thank you, I appreciate you.